Good morning, dear all. Now, I am going to discuss how to analyze data in STATA. Today, I will discuss some descriptive statistics, univariate analysis. But I would like to request you to please watch the previous videos based on data management, because without data management, it's not possible to analyze data in any software. So a data management part is mandatory. So please have a watch the previous videos. Today, I'm going to discuss just univariate analysis like mean, variance, frequency, percentage, etc. So as we know that for categorical variable, we use tab command to estimate proportion and frequency. For example, division is the category variable, rural, asset index, sex or genders. These are the categorical variable. So before analyzing the data, I would request you to please download the data from the video description. So if we would like to summarize the first category variable division, this is the division. If we type code book, So these categories are Borishal, Chittagong, Dhaka, Khulna, Mymensingh, Rajshahi, Rangpur, Sylhet is the administrative division in Bangladesh. So to summarize this data, just I have to type tab command. If we press enter, yes, this is the percentage and frequency. So if we'd like to summarize another category variable like place of residence, then tab, similarly tab wealth index, but if we are interested to summarize that all category variable using same single command, then type tab 1. I'm telling again, tab 1 command. This command will be used to summarize for all category variable. Then first variable, division, place of residence, wealth index, sex of child, then BMI cat, type of toilet, education, domestic violence, NC, stunting. These are the category variable. So if we press enter, okay, these are the category variable. Using single command, all category variables are summarized. And this is the syntax. So obviously I will provide the syntax in the video description. This is the command. These are for only category variable, but quantity variable like BR, browse like age, height, weight, child age, only 4 quantitative variables are available in this data set. These are quantitative variables. So we know that for quantitative variable, generally we use mean, median, standard deviation, etc. So first, mean. To estimate the mean, just we have to type sum command. This command for only mean and SD, minimum value and maximum value. Yes, this is the observation, mean, standard deviation, minimum, maximum. So similarly, if we give the all quantity variable in a single command, yes, these are the mean and SD, minimum, maximum for all quantitative variable. But if you'd like to assess the all summary statistics like mean, variance, standard deviation, median, skewness, curvature, all, then that we have to type D. D means detail. 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 This command for summary statistic for quantitative variable in detail. Press star. Yes, this is the first percentile, first quartile, median. 50% means median, third quartile, minimum value, maximum value, number of observation, mean, SD, variance, skewness, kurtosis. So using this command, we can summarize the continuous variable. Another command is mean. Just mean. Mean command also used to estimate the mean, but if we use this mean, then we can mean and confidence interval. Sometimes we need to estimate confidence interval, but today we won't discuss confidence interval because this is the inferential statistics. So when we will discuss inferential statistics, then we will use this command. Okay. This is mean, standard error, and confidence interval. Another command, a means. A means. A means command. This command is used to estimate the geometric mean, harmonic mean, and arithmetic mean. Sometimes we need to estimate the geometric mean, basically the biological data, biomarker data. So if we type a means and press enter, arithmetic mean, geometric mean, and harmonic mean. So we can use all variable, that means continuous variable. Yes. This is age, height, weight, and this is arithmetic mean, geometric mean, harmonic mean. This is arithmetic mean and confidence interval. So using this command, we can summarize the all type of variable. So after summarizing data, after data management part, we summarize the data using this type of command. Thank you very much. Good morning. Welcome to a new presentation. In the previous day, I discussed how to summarize data using univariate analysis like mean or proportion or geometric mean. Today, I'm going to discuss how to summarize data using cross-tabulation. Generally, for two categorical variable, we use crosstab. For example, tab. Tab division means summarize of division variable, then tab place of residence means summarize of resident type variable, then tab division and place of residence. The main advantage of STATA, the command or syntax is very easy. Just we have to type tab, first variable, second variable, then enter. This is the crosstab. This is the cell frequency. But if we would like to estimate the column percentage, then type just column, COL, column, full. This is the column percentage. Say more of. This is column percentage. And total 100%. If we would like to estimate the row percentage, just type RO or ROW, no problem. This is the row percentage, that means row total is 100. Another variable, ANC and type of place. This is 2 by 2. This is column. This is column percentage, that means total percentage is 100. Then another is row, is row percentage. If we would like to estimate column chi-square, then CAs and type this chi-square. So if you column percentage and chi-square, then column percentage and chi, row percentage and chi-square, then type. Sometime we need to estimate the expected frequency for 2 by 2 table, because if the expected frequency is less than 5, then we have to estimate the Fisher exact test. So expected means just EXP, just EXP type. This is expected frequency. It's very large. But if the expected frequency less than 5, then we have to type EXP EXA. EXA মানে EXA means Fisher exact test. This is Fisher exact test. But Fisher exact test will be applicable when the expected frequency less than 5. So this is the syntax, the previous syntax. Please download the data from my video description and please practice based on the syntax. And obviously, to know more, please watch the previous video on data management. Thank you very much.
Hi, good morning. Today I'm going to discuss how to create some statistical plot in STATA. So first of all, I request you to download the data from video description. And I'm opening the data. The data name is my data. So first we need to create data for continuous variable. For example, if we consider BR maternal height, this is a continuous variable. This is a continuous variable. So if we summarize, there is just some command already I've discussed. So to create histogram, that's hist. This command for hist. This is histogram. So if we would like to assess the bell-shaped curve, then just type norm. Hist variable comma norm. If we press enter, this is the bell-shaped curve. If we use another variable, for example, maternal weight, this is also continuous variable. If we use another variable, maternal S, respondents S, so using this command, we can create histogram. Now, if we would like to draw the box plot, this is the box plot. So if we type by another variable like place of residence, so we can compare two groups. We can use a multi-group, for example, asset index, the multi-group. Another variable, this is the dialog box of graphical representation. We can use any plot like distribution plot, that means quantile plot, normal quantile plot, if the values fall in the diagonal line, then we can say that the distribution of data is normal. Another, we can use normal probability plot, yes. From the normal probability plot, we can say that the distribution of data is normal. So using this procedure, we can create several types of plot. But for there are another plot, pie chart or bar diagram, although the stata is not appropriate for bar diagram, so graph frequency, so we can draw a bar diagram, and there are many options. We can consider the options, graph percentage, we can use percentage, we can give the legend, we can draw overall or by, etc. We can set the label, we can also round this value, etc. And this is the main dialog box. So when we will discuss the real data analysis, then based on our objective, we will create some valuable graph. Thank you very much. Good morning, dear all. Now I am going to discuss bivariate analysis where one variable is quantitative and other variable is binary or dichotomous or two category variable. For example, our the group variable is place of residence, urban rural, and a quantitative variable is maternal height or weight or BMI. So if we compare the mean between urban and rural, then which type of analysis we have to do? That means difference between two mean or mean difference. That means one outcome variable and group variable is place of residence. So we have to test the hypothesis difference between urban mean and rural mean. This mean divided by this mean. So obviously we have to check the distribution. If the distribution is not symmetric, then we cannot use the mean. In this situation, we have to use median. This is the another situation we will discuss later. So based on the histogram, we can see that the distribution is symmetric and approximately normally distributed. So now we have to test. The name of this is t-test. So we have to go to summary and classical test of hypothesis, then t-test. You have to click here. And two sample, we have to select two samples in group. And here the continuous variable and here the group variable, place of residence, for example. And there are two types of variance, equal variance and unequal variance. So we can see that the variance is approximately equal. So we can say that is the equal variance and we have to type. That means this is a syntax. This is the syntax t-test, continuous variable, comma, by the group variable. If we, yes. So this is the p-value. This is insignificant. That means we can say that there is no difference between urban and rural, difference mean of maternal height. If we see another variable, maternal weight, yeah, there is a significant difference between urban and rural. And the mean in urban is 54 kgs and the rural 50 kgs, and difference around 3.5 kg. There is significant difference. So this type of difference we can use t-test, but the variance is not equal. In this situation, we have to type just unequal. This is unequal variance. It is also significant. So if the variance is not equal, then obviously we should use two sample t-test with unequal variance. And this is the sentence. So please download the data from the video link and practice. If you have know the STATA software, then for practice purpose, I can provide you. So please knock me in my comment box, then I can share a STATA file for only practice purpose, not the updated version. It is the 14.2, STATA 14.2. So for practice purpose, this version is enough. So thank you very much. Good morning, dear all. Today I'm going to discuss about an important topic is correlation. To summarize the data, when two variables are continuous, in this situation, we need to use correlation coefficient to assess the association between two variables. In the previous session, I have discussed when two variables are category or one variable is category and other is quantitative. Today, I'll discuss when two variables are continuous. So first, we will open an example data set. Already, I have shared this data set in my video description. Please download. Hope you have downloaded from the previous session. This is our example data. So another request, if you have no knowledge on stata, the basic function, then please watch the previous video. Already I have created a playlist on data management. Without the knowledge on data management, it's not possible to analyze data. So first task of data analysis is data management. So please watch this video. So here two variables like maternal height. This is a common example variables. Height, this is the height, mean height is 150, and another variable is weight. So to assess this variable, to assess the association between two variables, first we need to create a scatter plot. Just yes, this is height and this is weight, and we can see that there is a positive association between or positive correlation between two variables. When height will be increased, then weight also will be increased. That means there is a positive association. So now we need to numerical measurement. It is called correlation coefficient. So the command is CORR, then weight and height. Since weight is, if we consider the dependency, then obviously height is independent and weight is dependent, because weight depends on height, but height doesn't depend on weight. So generally dependent, we put the variable first dependent, then independent. If we press enter, this is the correlation coefficient. Generally, we know that if the correlation coefficient is more than 80, then we can say that there is strong correlation. And if the correlation coefficient, the value is less than 25, then the relationship is very weak. But it is significant or not, to assess the significant relationship, just we have to type PW core. Just this is the command PW core, and in the end of the part we have to like sig. Sig means p value. For the cross tabulation, we use chi, the command chi to create the p value of chi square. And for the Pearson correlation, just we have to use this command p core sig. And this is the p value. Highly significant. The significance is high, but the relation is not so high because the value of correlation is less than 0.5. And p-value is highly significant because we know that if the sample size will be increased, then the p-value also lower. So if we use other variable like maternal age, so yes, there is a strong relationship. This is the negative. This is another issue. So this is the just correlation, and if we need the measure of dependency, then we need regression, but we will discuss regression later detail. Just the command is reg, and this is the regression coefficient. That means if weight increase by 1 kg, then a height also will be increased by 0.7 unit. And R square value is 0.17. That means weight depends on height by 17%. But I will discuss later. Today, my main objective of this session is correlation coefficient. So this is the syntax. Thank you very much. Hi, good morning. Today I will discuss about a interesting command named Tabstat command. Generally, this command will be used to summarize the continuous variable by a specific group. So please download the data from the video description. So now I am opening the data. Just click open. So ABC folder, the name of data is my data. These are data. So here there are some continuous variable like respondents S, BMI, not BMI, it is the height, weight, child S. Yes, these are program. So generally we type sum, then we get mean, standard deviation, minimum, maximum. But if we would like to get some specific statistic like skewness, kurtosis, variance, median, first quartile, third quartile, then how to do it? So there is a command named Tabstat command. So if we find out the summary from manually, then this is the path. Summary table, then other table, then compact table. This is the Tabstat windows. So we can choose the continuous variable. There are 4 variables. And if we can select the specific statistics, like for example, mean, second is standard deviation, fourth is, for example, median, third is, for example, 25% means first quartile, third quartile, etc. And if we summarize that by specific group variable, for example, place of residence, yes, place of residence, yes. Then tap yes, this. So these are the 4 variables, and this is the group variable, urban, rural, and total, and mean is D. This is the median, first quartile, third quartile. So this is the command. So this is the command, and this is our data. So if we summarize data by another variable, this is the place of precedence. If we would like to summarize data versus education, then just we have to type education variable and run. Yes, now it is summarized by education. If we'd like to another variable like asset index, so we can keep the asset index as a group variable and then click here. Yes. So the data have been summarized by wealth index, poorest here, mean, variance, etc. If we would like to change our another statistic, like for example, mean SD, not median, if we like to count n, then mean, max, then type, yes. This is minimum, this is maximum, this is count. How many variables? And total is 8,616. So using this procedure, we can summarize the continuous variable easily using Tabstat command. So thank you very much. Good morning, everyone. Today I'm going to discuss an interesting topic that how to summarize continuous variable against a category variable. For example, just I'm opening the data set, ABC folder and my data. Already I've shared the link in the video description. Please download this data from the link and practice yourself. So if we see that the tab wealth index or tab division, so this is the frequency for category variable, and another variable is continuous variable like BMI. And this is the summation, but I would like to find out the mean and standard deviation for all category variable against all category variable. So tab, comma, sum this variable. Okay, this is the command. Now, what is the meaning of this data? In the Borishal side, or based on the Borishal division, the maternal height 151 and the standard deviation is 5.52. If we use another variable like maternal weight, then this is the maternal weight 51 kg in the Borishal division with the standard deviation 9.82, and the frequency or number of participants in the Borishal division is 896. If we use another category variable like wealth index, then we can get mean, SD, and number of observations. So I'm discussing this analysis because in the next session, I will discuss ANOVA, one-way ANOVA, two-way ANOVA. So if we discuss one-way ANOVA, then we will need this type of analysis. So please practice yourself using the given data set. Then please, if you face any problem, then please comment in the comment box And obviously, I would request you to please subscribe to my channel. Thank you very much. Good morning, dear all. Today I will discuss ANOVA, that means analysis of variance in stata. So first of all, I'm going to open the data set. Already I have shared the link in the video description. Please download this data set for practice purpose. My question, when do we use ANOVA? Generally, we use t-test for comparing a continuous variable between two groups. That means if the group size is 2, for example, the group sizes of place of residence is 2, so compare the mean between, for example, maternal weight is the mean. So if we use maternal weight, then the mean in the urban area, this is mean in the rural area with standard deviation. So if we'd like to compare between two groups, then just we use t-test by place of residence or any binary variable. That means there is a significant difference. But my question, if the number of category more than 2, like acid index, so how to solve this problem? That means we'd like to sorry. We'd like to assess the variation between the group. That means we'd like to any significant difference among the group. Then we won't use t-test because t-test will be used for only two groups. So in this situation, we use ANOVA. Just go to the statistics, then linear model and ANOVA, then analysis of variance. So here dependent variable is continuous variable and the model is this is the ANOVA. So if the p-value is significant, then we can say that there is a significance between any group. But which group we don't know. So another method is one-way ANOVA. Then we use one-way ANOVA. This is called one-way ANOVA, and response variable obviously a continuous variable, factor variable, a category variable like asset index. So yes, this is the ANOVA table. But before going to interpret the main result, we should assess the Bartlett's test. Bartlett's test used for the equal variance. If the p-value is insignificant, then ANOVA will be applicable. But remember, please, when the sample size is large, I'm telling again that if the sample size is large, then we get the significant result. In this situation, we should use another test, just box plot, but the graphical. If the sample size is large, then the graphical representation is very important, like box plot. Already we discussed the box plot. Go to the box plot, then maternal weight, and the group variable is asset index, but wealth index. Yes, this is the group variable, and we can say that the boxes are like similar. So there is no significant difference based on the variance. There are some outlier. This is another issue. So in this situation, we can use ANOVA. So the p-value is significant means there is a significant difference between any two mean. Either these or these or these or these or these or these, but I don't know which pair is significant. In this situation, we have to use the multiple comparison test like Bonferroni or SIDAC or Shafi. We will use Bonferroni, for example. Then if we press submit, Yes, this is significant, and this group, poorest, poor are significant, 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 all are significant. If we use another group like division, is Dhaka versus Khulna, there is no significant difference, or p-value exactly 1, Dhaka versus Chittagong, there is no significant, Dhaka versus Borishal, there is no significant, Borishal versus Rajshahi, there is no significant. On the other hand, Rajshahi versus Chittagong, significant, etc. Then, from the Bonferroni correction, Bonferroni analysis can identify the which pair is significant. So, this is our ANOVA. So, if we would like to produce the summary, then we can click here, or we can, if we need the table, other table, then click here, etc. So now another objective of ANOVA is to identify the ICC. There is any inter-class correlation within group, then we can use ICC, intra-cluster correlation. So linear model, ANOVA, then large one-way. Just we have to type large one-way ANOVA. So click here. So response variable, for example, maternal weight, group variable, for example, the division, then we submit. Yes, the intra-class correlation 0.3. So to estimate the sample size, or to assess the correlation within group, we can use this command to estimate the intra-cluster correlation. So this is the application of ANOVA. So if you face any problem, then please comment in the comment box. Then we will discuss. My objective or making video is to learn myself. That means I would like to learn many things. So if you give some feedback, then it's very easy to learn STATA or statistical modeling. Thank you very much. Hi dear all, good morning. Today I'll discuss about non-parametric tests. Recently we discussed the parametric tests. Today I will use just non-parametric tests, but we won't use any advanced statistical analysis like regression or quantum regression. Just we will discuss the bivariate relationship. To assess the bivariate relationship, we use chi-square, t-test, ANOVA, and some non-parametric tests. My question, why do we use non-parametric tests? So please open the data. Already I've shared the link in the video description. Please download the data for practice purpose. So generally we use non-parametric tests when the continuous variable, that means main variable, outcome variable, is not normally distributed or symmetric, or there are some outlier. For example, histogram. So maybe there is no asymmetry. This is symmetric data. So if we consider a norm, yeah, this is almost normal distributed data. So if we estimate summary, sum, and here D. So mean and median almost similar. So we can say that there is no outlier, but suppose this is not normally distributed. So if our outcome doesn't follow the normal distribution, then we can use non-parametric test. So please go to the statistics summary and non-parametric test. So there are many tests, Kolmogorov test. These are for the normality tests, but we will use only a test, Wilcoxon tests and Kruskal test, median test, etc. So if our data, like if we like to compare only two group, then we use Wilcoxon. So outcome variable is maternal weight. Sorry. Wilcoxon rank some test. It is called also Mann-Whitney test. So maternal weight and group variable is place of residence. Then, yes, that means they're significant. If we use median, then we should use this test. This is called a rank sum test. Another is median test. So this is the median test. So here maternal weight and group variable is place of residence. So this is called median test. But when the group variable is more than one, like this variable, then we use Kruskal test. So non-parametric test, Kruskal. So outcome variable is maternal weight and group variable is submit. That means there is a significant difference. But my question, if we would like to estimate multiple comparison tests like Bonferroni test, then how? So the test name is dunntest. D-U-N-N, done. So dunntest. So if your stata version is lower, like 13, 14, or 15, then obviously you have to install this package, just SST install done test. Sorry, done test. Or if your version is 17 or 18, then you don't need to install this test. So first of all, we have to click, we have to analyze this. Then just to test the done test, just we have to type the done test by group. Then we have to type just Bonferroni. Yes. Either. Just like Bonferroni for ANOVA, similarly, just we have to use dunntest. This is the overall significant level, and this is the pairwise significant. There is no significance between Borishal and Khulna. Since the data is not asymmetric, so ANOVA and dunntest, the results will be similar. So if you'd like to analyze this type of analysis mainly, then you can use this test. So just This is our syntax. Thank you very much.